Myself, Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about binary multiplication. At the end of this video, the student will able to gain knowledge about how to perform binary multiplication, what is the necessary hardware that is required to perform this multiplication, and the flow chart or the flow of operations involved in the binary multiplication. The basic agenda of this video is giving introduction regarding the binary multiplication, the examples to perform the binary multiplication, the hardware components needed for binary multiplication, what is the flowchart for the multiplication, and how array multiplication can be implemented. So, in the previous videos, I discussed about the binary addition subtraction, how this addition subtraction can be performed with necessary electronic circuitry. But in this video, I will discuss about the binary multiplication, which involved a little complicated process. So here we will discuss this binary multiplication. First, how to perform this multiplication with examples. Then we will move on to the electronic circuitry that is needed for the multiplication process, how the flowchart of operations that can be carried out in the multiplication process. With an example, we will discuss that. So here, if you consider the binary multiplication, two numbers are involved in the multiplication. So here, this binary number is used as the multiplicand, and here this number is used for the multiplier. How this multiplication can be carried out? So here the LSB of the multiplier can be considered first. So it is a 1. 1 multiplied by any number can be the same number. So 1 multiplied by the multiplicand, the same number has to be copied here. Next bit has to be considered in the multiplier, that is the 0. In case of a binary system, only the possible digits are either 0 or 1. In case of 1, the multiplicand can be copied in the partial product. In case of 0, all zeros can be copied in the partial product. So here, the second bit that is considered is 0. So, the multiplicand, how many number of bits are there in the multiplicand, those number of zeros can be copied by shifting one position. By shifting one position, here the partial product can be copied. Next bit can be considered in the multiplier. It can be 1. So, the same multiplicand can be copied by shifting one bit in the partial product. So, like this, how many number of bits are there in the multiplier? So, each bit, if it all the multiplier bit is 1, the same multiplicand can be copied. Otherwise, by shifting one position in the partial product. Otherwise, the 0 is there. The number of zeros, the number of bits in the multiplicand, how many bits are there, that many zeros has to be copied by shifting one position in the partial product. After writing all partial product terms, those terms has to be performed the addition. So, this is the binary product. So, this is the way how the decimal number system we are performing the multiplication. So, multiplier, each digit has to be involved in the multiplication, and by multiplying each digit with the multiplicand, by writing partial product by shifting one term, after completion of writing all partial product terms, addition can be performed. In the similar way, in binary multiplication can be done with the same thing. But here, in the binary system, only the possible digits are zeros and 1. In case of 1, the multiplicand can be copied in the partial product. In case of 0, the number of bits involved in the multiplicand, that many zeros can be copied in the partial product by shifting one position. And after that, the partial product terms can be added in order to produce the result. Now we will consider one more example to gain knowledge about the binary multiplication process. For example, consider a 4-bit. This is the multiplicand. And consider a multiplier. This is the multiplier. And how to perform the binary multiplication. So here, while performing the multiplication, first we have to consider the LSB of the multiplier, and it is a 1. So multiplicand has to be copied in the partial product. So 1, 1, 0, 1 can be copied in the partial product. So this bit can be completed. Now consider the next bit, that is the 0 bit. How many number of digits are there in the multiplicand? That many zeros can be copied in the partial product by shifting one position. So from here 0, 0, 0, 0. So this bit can be completed. Now consider the next bit, 0 bit. And with this 0, number of bits in the multiplicand copied by shifting one position. So 0, 0. Next bit is 1. So in case of 1, the multiplicand can be copied by shifting one position. So here we have to write the multiplicand. So all these are the partial product term. Then we have to perform the addition. So here 1, 0 plus 0, 0, 1, 0, 0, 1. 1, 1, 0 with a carry 1, 1, 1, 1. So this is the result or the product term of the multiplicand and the multiplier. So in this way, the binary multiplication can be performed. So with this process, you can gain what are the operations involved in the binary multiplication. After discussing about the circuitry or the hardware component needed for the binary multiplication, we will move on to the flowchart of the binary multiplication. So this is the hardware implementation of the binary multiplication. So in order to store the multiplicand and the multiplier, 2 registers are used. So here the B register can be used to store the multiplicand. And the sign of the multiplicand can be stored in a flip-flop B sign. And the multiplier is stored in the Q register. And the sign bit of the multiplier is stored in the Q sign. And the last bit LSB can be stored in the QN. So here we have to take the bit by bit by using the QN value. How many number of bits are there in the multiplier is stored generally in the sequence counter. So here the partial product can be stored in the A register and the sign bit, and during that any extra addition, if any carry is produced, that has to be stored in the E flip-flop. So for partial product writing and adding of that, the required component is complementer and parallel adder. So these are the electronic components that are required in order to perform the binary multiplication. So first, whenever you are moving to the flowchart of the binary multiplication, we have to once again look into the flow of performing binary multiplication. So multiplicand is stored in the B register, multiplier is stored in the Q register, and the number of bits of the multiplier can be stored in the sequence counter. First, it is initialized with the how many number of bits are available in the multiplier. So here 8 bits are there. So sequence counter is initialized with the 8. And here the Qn means the last bit, LSB bit of the Q can be considered here as Qn. And we are checking whether this Qn is 1 or 0. If at all this Qn is 1, the multiplicand value 1 multiplied by the multiplicand, same thing that can be applied. So the multiplicand value has to be moved to the partial product term. And this digit is considered for the multiplication, and we are moving to the next, considering the next digit for the Qn by decrementing the counter to the 1 value. So here the Qn value is compared, either it is 0 or 1. If it all 0, how many number of bits in the multiplicand is there, that many zeros can be written here by shifting the 1 position. Here shift operation can be applied. So like this, each and every bit has to be considered by decrementing the sequence counter until the sequence counter is 0. The multiplication can be performed and partial products can be written. At the end, the addition can be performed in order to find the product of the multiplicand and the multiplier. So this is the flow of operation that can be carried during the binary multiplication. Now you have to look into the flowchart of the binary multiplication. So multiply is the operation. Two numbers can be considered, that is multiplicand and multiplier. Multiplicand can be stored in the B register. Multiplier is stored in the Q register. In order to determine the sign of the product, we have to compare the signs of multiplier and multiplicand with the XOR operation. So when you consider the XOR truth table, for two numbers, so the truth table of XOR logic can be when both input numbers can be the same, 0, 0, 1, 1, then the output XOR operation is 0. If the both numbers can be different, the XOR operation can be 1. So in order to check the signs of the both registers, the XOR logic can be implemented. Whether the multiplier multiplicand can contain the same sign or different sign. So here by using this, if the XOR operation is result in 0, then multiplier multiplicand can contain the same sign. Otherwise, they can contain the different sign. So here the sign comparison can be done. And the partial product register is initialized with 0, and extra carry bit, that is flip-flop, E flip-flop, can be set with 0. The sequence counter can be initialized with how many number of bits in the multiplier. So how the process of operation can be considered. So here Qn is the LSB of the multiplier. The LSB of multiplier can be taken. In binary number system, only there is two possibilities. One is either it can be 0 or it can be 1. So whether the Qn value is 1 or 0, that can be compared here. If Qn contains the 1, the same multiplicand has to be moved to the partial product. So here extra along with if it all carry produced, then the A plus B can be done. Multiplicand plus the partial product value can be done, and the result can be moved with the EA. Flip-flop E and A register the partial product register. And after that, the shift operation has to be performed to move to the one position. Shift right operation has to be applied. And one bit is we consider. So, the sequence counter can be decremented by 1. SC is SC minus 1. Next, we are moving to check whether SC value is 0. If sequence counter is 0, the process is end. Otherwise, we have to repeat these steps. Again, taking the next bit of the multiplier and checking whether it is 1 or 0. If it all 1, the addition operation can be performed. Next, shifting operation can be performed. If the bit is 0, only shifting operation can be performed. Why? Because only we are writing in the partial product how many number of bits of multiplicand zeros are there. Those zeros has to be used here. And for any number, if we add the 0, the same number we can get. That's why here no addition. So shift right operation can be performed. So this process can be repeated until the sequence counter value can be 0, which means that there is no bits to consider for multiplication in the multiplier register. So at this stage, we have to end the flow of execution. So this is the multiplication flowchart. Now, with an example, we have to discuss about the multiplication flowchart. So here I am considering the multiplicand B as 0, 0, 1, 0. So we have to consider the E. E is extra carry that can be produced. Initially it is 0. A is the partial product storage register, and how many number of multiplier bits are there, that many zeros can be initialized with A. So here 4 bits are there. So we have to initialize with 4 zeros. A. And what is the multiplier? Q. Q is 0, 1, 1, 0. Okay. Next, the SC sequence counter value has to be initialized with how many number of bits in the Q. Whether you can represent in the decimal or binary the sequence counter value. Okay. So here until this the initialization process, here A is initialized 0, E is initialized 0, and sequence counter value has to be equated with the number of bits in the Q. This step the example is considered. Next, we have to consider the Qn value, and a check can be performed whether the Qn value is 0 or 1. If it all 1, the A plus B operation can be carried out. Later on, shift right operation can be performed on EAQ registers. Okay. So here we have to take the Qn. So here Qn is the LSB of the Q. So here this is the Qn. So Qn is 0. So Qn value is 0. We have to compare whether Qn is 0 or 1. So here Qn is 0 or 1. It can be the 0. Then what? The flow of operation. So shift right EAQ and decrement the counter value. So we have to perform the shift right operation on the EAQ. So here the shift right operation, this bit can be moved to A. Like this, the shift right operation can be performed. And this bit can be discarded, and here this can be equated to 0. So this is the shift right operation performed when Qn value is 0. And we have to decrement the counter by 1. So SE value is 3. Next, we have to compare the next Q1 bit. So this is the Qn bit. So Qn is equal to 1 here in the next step. In case of Qn is 1, what we have to do? Qn value is 1 means then the A plus B operation can be performed. Later on the shift right operation is performed and decrement the counter value. So here Qn is equal to 1. So for the A, the B value can be added. The B value multiplicand value is 0, 0, 1, 0. This can be added. So 0, 1, 0, 0. E value is 0 and Q value is 0, 0, 1, 1. So after addition, the shift right operation can be performed. So here we are performing the shift right operation on EAQ. So here shift right operation whenever you perform with 1 bit movement, and this value can be discarded and here is 0. And decrement the counter with 2. Okay. Next, consider the again Qn value. So here this is the Qn. Qn is equal to 1. So we have to perform the shift right EAQ after adding the B value to the A. So the B value is 0, 0, 1, 0. This value can be added to the A. So 1, 1, 0, 0. This is the E value and Q value is 0, 0, 0, 1. So again the shift right operation can be performed on the EAQ. So here this is 0, 0, 0, 1, 1, 0, 0, 0. And this bit can be discarded and counter can be decremented by 1. And again the Qn value can be considered. The Qn can be 0. In case of Qn is 0, no addition operation can be performed. Only shift right operation can be performed. So we have to apply SHR on EAQ. So here shift the operations here. And decrement the counter 0. So here this process, these steps of operation can be repeated until the sequence counter value is 0. If sequence counter value is 0, end the process. Otherwise, repeat the process. So, if you observed here at this stage, the sequence counter value can be the 0. So, stop the process. What is the resistors that contains? So, that is the product. So, this is the end product of multiplication algorithm. So, internally, the electronic components can be used to perform the flow of binary multiplication in this way. So, in a simple way, first we have to perform the initialization process. During initialization process, the partial product storing resistor A can be initialized with 0 and extra bit hold flip-flop can be 0 and sequence counter can be initialized with the number of bits of the multiplier. And here the multiplicand can be stored in the B resistor, multiplier is stored in the Q resistor. The LSB of multiplier Qn can be taken into account and compared whether it is 0 or 1. In case of Qn is equal to 1, the addition operation can be performed, A plus B operation can be performed, and result can be stored in A and the extra flip-flop bit E. The carry is stored in the E. Later on, shift right operation can be applied on EAQ and decrement the counter value by 1. And next, we have to compare the sequence counter possesses 0 or any value. If other than 0, again these steps can be repeated. If at all Qn is 0, directly shift right operation can be applied on EAQ and the sequence counter can be decremented. If sequence counter value is 0, then end the process. The resistors, whatever the content of the resistors contained in the EAQ is the product. So in this way, the binary multiplication can be carried out. So consider one more example. So here multiplicand is 10111 and multiplier is 10011. So here the multiplicand and E is initialized with 0. A is initialized with the number of bits of the multiplier. Q is the 10011 and counter can be initialized with the value 5. This is the binary equivalent of 5. How many number of digits there in the multiplier? And checking here Qn value, it is 1. So addition with the multiplicand can be performed here. After that, the shift right operation can be applied on EAQ. Then decrementing the sequence counter. Next, the Qn bit can be considered and it can be the 1. Again, addition operation can be applied and shift right operation can be applied on EAQ. Decrement the counter. So it is 3. And checking here the Qn value is 0. So addition operation is no need here. So shift right operation can be performed on EAQ and sequence counter can be decremented. So this process can be repeated until sequence counter can be 0. And the final product can be available in EAQ. So that EAQ value is the result. So in this way, the binary multiplication algorithm can be applied. Another variety of multiplication is available, that is array multiplication. Array multiplier is a digital combinational circuit which can be used the half adders and array full adders to find the multiplication. So here the array is used for the nearly simultaneous addition of various product terms involved. The partial products can have to be stored in the array and these product terms can have to be developed by using the AND gates. After that, these terms can be added with full adders and half adders. So the array multiplier is a digital combinational circuit that can be used the AND gates, full adder and half adders. How this array multiplier can be performed the binary multiplication. Consider two numbers. Here the multiplicand is B, B0, B1, 2 bits are there. And the multiplier contain 2 bits, A0 and A1. So how the product can be performed? Considering the LSB of the multiplier and multiply with these 2 bits. So here the first product term is A0, B0 and second product term is A0, B1. After considering this bit, next we have to move to the next bit of the multiplier. So here we have to apply the product operation by considering the second bit of the multiplier. So here A1 B0 is the product. Here shifting one position has to be left blank and A1 B0, next A1 B1. So after writing the partial product, addition operation can be performed. So this term addition can be taken as C0 and these both terms can be added and the sum can be represented in C1, A1, B1, C2. If carry is presented, that is represented with the C3. So we taken 2 bits of multiplicand B and multiplier as A. How this array multiplier circuit can be built based on this example of multiplicand B and multiplier A consists of 2 bits. So this is the AND gate. This AND gate receives 2 input B0 and the A0. So here the product has to be produced here A0 B0. So if you observe the last term, the product is A0 B0. These two terms can be given as input to the AND gate. So here the product term A0 B0 can be produced. So the sum is C0. So here C0 is represented. The next term can be used here to AND gates. The AND gate B1 and A0 can be produced here. So here B1 A0 and here B0 A1. A0 B1 B1 A1 B0. These two terms has to be added with a half adder. If it all the sum bit is C1, the carry if it all produced, that is given to the next half adder, the cascaded half adder. And the next term is here A1 B1. So A1 B1 is given to the AND gate and the product A1 B1 is produced here. It can be given as input to this half adder. And the C2 is the sum. If it all carry is produced, that is the C3. In this way, array multiplication is a electronic combinational circuit that can be constructed with AND gate, half adder or full adders to produce the binary product. So in this video, I discussed about how simple binary multiplication can be done by taking two numbers. So what is the process of binary multiplication? Next, what are the electronic components that can be needed for performing the binary multiplication? So the process flowchart that involved in order to produce the binary multiplication. By taking one example, multiplicand and multiplier, how this flowchart can be used to produce the product. With an example, we discussed that. Not only this, another variety is binary multiplier. So how electronic combinational circuit with AND gate and the half adder full adders can be used to produce the binary product. Another variant multiplication algorithm can also be available. That algorithm is called Booth's multiplication algorithm. We'll discuss that Booth multiplication algorithm with examples in the next videos. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.